Hello everyone, my name is Neeraj Kumar Pandit and I am a student of IIT Kanpur, and today I am going to teach you a very important concept in mathematics, system of linear equation. Before starting this chapter, we have arise question in our mind: what is linear equation and what do you mean by system of linear equation? Then what is linear equation? An equation in which every variable of degree is 1 is known as linear equation. For example, ax plus by plus cj is equal to 1. This is linear equation because every variable x, y and z has degree 1. a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. And a3x plus b3y plus c3z is equal to d3. This system of linear equation can be written as ax is equal to b, where a is coefficient matrix and b is column matrix. And we define delta. Delta is nothing. Delta is determinant of a, which is coefficient matrix of determinant. A1, B1, C1, A2, B2, C2, A3, B3, C3. And delta 1 defined. Only column 1 replaced by this column matrix. D1, D2, D3, B1, B2, B3, C1, C2, C3. Similarly, delta 2 defined. Only replaced by second column matrix as this matrix B in delta. A1, A2, A3, D1, D2, D3, C1, C2, C3. And delta 3 defined. A1, A2, A3, B1, B2, B3, D1, D2, D3. Now, by Cramer's rule, x is equal to delta 1 by delta, y is equal to delta 2 by delta, and z is equal to delta 3 by delta. Here questions arise. Here system of linear equation has solution consistent and inconsistent. Solution is consistent when if delta not equal to 0. Then system of linear equation has unique solutions. If delta is equal to 0 and every delta 1 delta I is equal to 1 to 3 is equal to 0, then system of linear equation has infinitely many solutions. And if delta is equal to 0 and at least one delta I is equal to 1 to 3 is non-zero, then system of linear equation has no solutions. This system of linear equation is non-homogeneous because RHS is not equal to 0. If RHS is equal to 0, then AX is equal to 0. In non-homogeneous case, solution is consistent and solution may not be consistent. But in homogeneous case, solution always consistent. It has unique solutions and it has infinitely many solutions. Let's start system of linear equation in non-homogeneous case. Ax is equal to b, where A is equal to coefficient matrix 1 1 1, 2 minus 1 1, 1 2 minus 1, and b is equal to 6 3 3. We know that determinant does not change when we apply row reduced form. Hence, we apply row reduced form here. In this situation, how to apply? We apply in second row of first integer 0 and third row of first integer 0, and we get this matrix. And R3 replaced by R3 plus 1 by 3 R2, and we get this matrix. And this matrix is delta, which is determinant is equal to product of diagonal entries, which is delta is equal to 7, and delta 1 replaced by this column matrix, and we got delta 1 is equal to 9 determinant, and similarly delta 2 is equal to 15 and delta 3 is equal to 18. We replace our for simple calculation we apply row reduced form. Let us move into non-homogeneous system of linear equations. Has no solution, that is inconsistent. X plus y plus z is equal to 6, 2x plus 2y plus 2z is equal to 12, x plus 2y plus z is equal to 5. Here coefficient matrix A is equal to 1 1 1, 2 2 2, 1 2 1, and B is equal to 6 12 5. Here AB is equal to 1 1 1, 6 2 2 2, 7 1 2 1 5. We know that determinant does not change if we apply row reduced form. Here we apply row reduced form and we get this matrix. Here the delta is this thing total, and which is 0 because every element of second row is 0, and delta 1 is equal to this. We replace first column by this column matrix, and we get minus 5, and delta 2 the second column is replaced by this matrix, and delta 2 is equal to 0, and delta 3 third column is replaced by this matrix, and this is equal to delta 3 is equal to 5, and hence hence no solutions. Due to delta 1 and delta 3 non-zero and delta is equal to 0. In our theory, I say that if delta I upon delta I at least one non-zero and delta is equal to 0, then we get no solutions. Let's move in homogeneous system of linear equation. For example, this a1x plus b1y plus c1 is z is equal to 0. Let us start in homogeneous system of linear equation. a1x plus b1y plus c1z is equal to 0. a2x plus b2y plus c2z is equal to 0 and a3x plus b3y plus c3z is equal to 0. Ax is equal to 0 where A is equal to coefficient matrix this and determinant of A is equal to delta. Case 1, if delta not equal to 0, then system has trivial solution. That means 0, x, y, z all are 0. We see by example. And case 2, if delta is equal to 0, then the system has infinitely many solutions. Let's move in for example, x plus y plus z is equal to 0, y plus z is equal to 0 and z is equal to 0. Coefficient matrix A is equal to this and delta means determinant of A is equal to 1. Then A matrix is invertible and x is equal to 0, x is equal to A inverse 0 which is 0. That means x, y, z is equal to 0. Trivial solutions. And x plus y plus z is equal to 0, 2x plus 2y plus 2z is equal to 0 and z is equal to 0. Here coefficient matrix 1 1 1 2 2 2 0 0 1 x y z is equal to 0 0 0 and hence R2 minus 2 R1 that implies these conditions and z is equal to 0 by this z is equal to 0 or x is equal to minus y. That means we take t into 1 comma minus 1 comma 0 where t belongs to R. That means infinitely many solutions.